NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Recorded Future. They help security teams make more confident decisions faster. Recorded Future's technology automates broad collection and analysis of cyber threat data and delivers the rich external context you need to understand alerts and emerging threats. With real-time threat intelligence from Recorded Future, security teams respond to threats 63% faster and find undetected threats 10 times quicker. To get started, go to recordedfuture.com/Security Weekly and sign up for the Recorded Future Cyber Daily. Every day, you'll receive an email with the top results for trending technical indicators, cyber news, exploited vulnerabilities, suspicious IP addresses, and more. Subscribe today and stay ahead of cyber attacks. Endgame's converged endpoint security platform is transforming security programs, their people, processes, and technology with the most powerful endpoint protection and simplest user experience, ensuring analysts of any skill level can stop targeted attacks before information theft. Endgame unifies prevention, detection, and threat hunting to stop known and unknown attacker behaviors at scale with a single agent. For more information, visit endgame.com. Welcome back, everyone, to Paul's Security Weekly. A quick announcement before we get started. We have exciting news about the Security Weekly webcast program.
Exciting nudes?
No, not exciting. No, news. That gets you CPE credits. And you don't get CPE credits for nudes, Larry.
Damn it.
But you do get CPE credits because we're partnered with ISC Squared as an official CPE provider. If you'd like to attend any of our webcasts, you will get 1 CPE credit per webcast. You can also buy me a beer at Black Hat, and I may give you a No, it's I wish that's how it worked. It's not. You have to register for our webcast or register for one of our on-demand webcasts. You can do that securityweekly.com/webcast.
But that sounds like a great program. CPEs for beer?
Yeah, we need to talk to ISC Squared. But anyway, our next webcast is actually from Signal Sciences, who this interview is with as well.
Excellent.
But Zane Lackey of Signal Sciences is coming on. He is the man. We're gonna. It's interesting. Zane, Matt Alderman, and myself are going to be talking about. Well, we're going to use the application we've been developing for the past couple of months, and as an example, and then talk about how we can protect that with Signal Sciences, where the feedback loops are, in all of the kind of architecture and where the rubber meets the road in terms of application security. All with again Zane Lackey, myself, and Matt Alderman. SecurityWeekly.com/webcasts. Get your CPE credits in addition to fun, entertaining, and educational webcasts. This segment is actually sponsored by Signal Sciences as well. Doug Coburn is the Signal Sciences Director of Professional Services, where he leads the team that installs Signal Sciences at customer environments. Prior to Signal Sciences, Doug entered the alphabet soup, IaaS, PaaS, FaaS world with Iron.io, doing serverless functions as a service, leading their sales engineering team. Doug, welcome to the program.
Thank you for having me. Excited to be here.
It's very nice to have you. Those that want more about Signal Sciences technology can visit signalsciences.com/PSW. And I encourage you to do that because we've worked with Signal Sciences for a long time, and their product is really awesome. And actually, in prep for our webcast, Doug, we're going to try and do a deployment inside of our own internal app for Signal Sciences, which is going to be, we've talked about doing that for so long, and now is the time, is what I'm saying.
Oh, well, me and my team are the ones that can help you do that too, get it up and running.
After Black Hat, we're going to talk. Absolutely. I can't wait. It's going to be a lot of fun. So Doug, how did you get started? Did you start in application security or in applications and then kind of make your way into information security? But how did you get your start?
Yeah, so I actually started back with endpoint management with BigFix that eventually got acquired by IBM. And there we started, obviously we're doing patch management, which was security related, and then also security compliance. And after that, I moved to a few other companies, one of which was Mocha 5, which was a desktop virtualization and security. And then eventually got into Okta and Iron.io and started transitioning more into protecting the apps as opposed to the whole system.
That's awesome. So, Doug, so what is your role today? You assist customers that are implementing Signal Sciences?
Yeah, so I do a little bit of everything. Obviously, I'm running the actual professional services team here. I also still run and manage our accounts for some of our large enterprises and do day-to-day installs and helping them give best practices and actually just get things working and extending the functionality of the product.
That's awesome. So, Doug, for our audience, if you have an application that you want to primarily protect, right, which is what, monitor and protect, right, which is what Signal Sciences does, just walk through some of the deployment options that you have available. I find that, well, first describe the problem you solve, and then talk about how it's deployed. So those are two very basic things that that our audience would really appreciate hearing.
Be my pleasure. Yeah, obviously, we've had Zane, as he already mentioned, and Nick and Andrew come from a practitioner background. So the problem that they were trying to solve was issues that they had with traditional and legacy web application firewalls, being single points of failures, high latency, high rates of false positives, and being very difficult to get it into a blocking mode. But that was their goal with Signal Sciences, was how do we actually solve those issues? And part of that is also being able to install pretty much anywhere. So the installation methods allow you to do really anything. You can have it be in the web server layer, Apache, Nginx, HA proxy. It can be at the code layer, Java, Python, PHP, Node.js, etc. It can be in a reverse proxy mode where we just sit in front of the web application, or it can be in our newest version in the Cloud WAF where you just change your DNS and everything kind of goes through us in order to be able to protect against injection type attacks, business logic type events, API abuse, and a whole other slew of things that our customers are using to protect their web applications from attacks in the wild.
Now, when you say that you deploy it as part of your application, whether it's Python or Java or whatever, I think we need to make the distinction between like you're deploying on containerized environment or not, correct?
Really, at the end of the day, it's the same. So containers, and I would say the majority of our customers now have at least some kind of Kubernetes or other container-based installation. And those containers are running a operating system. Granted, they're using a shared kernel space. And often they're running some kind of microservice that is either one of those code layers. Node.js is a pretty common one. Or they're running something like Nginx or HA proxy Envoy at the ingress layer. So the actual installation methods are the same. It's just how it's wrapped up into that container.
I gotcha. Because, I mean, if you're in a container, what we've talked about on the show in the past that I want to highlight for our audience again is the deployment. We talked about like time to value and ease of deployment. When Zane and others described it to me, I'm like, hold on, you're saying like it takes customers an hour or two or whatever. But really what you're describing is like I make one change to a Docker Compose or a Docker file and I include the module. I'm like, that's like maybe 15 minutes at best. And they're like, yeah, that's the reality, but no one believes us.
Yeah, that's usually, we find actually 5 to 15 minutes is the normal for installation. But when you tell people that, they go, yeah, you're full of it. And so we use bigger times to make them sound more believable.
I think that's awesome. That like we can't fathom a security product being that easy to deploy, so we have to basically say it takes longer so people believe us. That's insane.
Yeah, on average, when I'm with a customer and we do our installation, the 6i agent and module part is usually 15 minutes or less. Any other time that we spend on it is usually more change control, updating GitHub so that you have your CI/CD, but the actual implementation is almost nothing.
That's awesome. That's awesome. So tell us a little bit, Doug, about Kubernetes, because I have to be honest, I have not done a Kubernetes implementation yet. My experience in that realm is really Docker and Docker Compose. I've read about deploying into environments such as Azure, AWS, Google Cloud, Fargate, and things of that nature. And they all have, their support for Kubernetes or similar kind of things. But like at what point do you have Kubernetes and how does that change your deployment of Signal Sciences?
Yeah, so Kubernetes in of itself is the underlying technology for most of those ones that you just mentioned that's doing any kind of containers. So there's often an abstraction layer from Kubernetes where you have some of your own definitions of how you do it in those platforms, but that underlying technology remains the same. You're really just doing container orchestration. And I would say in most cases, doing Kubernetes directly is actually easier
Mm-hmm.
because you now have some pretty common standards for YAML or JSON files, and you just put things in and you can copy it from platform to platform. So from an installation perspective, the way Kubernetes and most of these platforms work is you go off and define your Docker container, test it locally on your laptop or wherever you would like. And then you take that same container spec, pop it into a YAML configuration file, and that's usually called a deployment, drop it into Kubernetes either via the CLI or UI, although I think most Kubernetes admins you'll find use the CLI.
Mm-hmm.
Apply that deployment and it distributes it. You can also set up great things like auto scaling. So if either the web app or in this case, the protection, the web application firewall starts getting close to its resource bounds, you can scale up, have more containers, and then scale back down when the load decreases again.
That's interesting. So, can you have just kind of an off-topic question, but multiple containers that perform the same function that can increase your capacity and/or performance?
Yep, that is exactly what pods are. So pods are a container of containers, and they have
Mm-hmm.
definitions for auto-scaling policies, also things like shared volumes, so that things could communicate or have a shared drive. You can also have namespaces that are specific to it. And this allows you to be able to have things securely communicate. And then each pod, as they reach capacity, a new pod with a new version of your web app and anything else that's in it gets spun up. And because the way the container space works in this environment is supposed to be stateless, this means you could spin up 1,000 containers as long as your hardware could support it without any real issues. And they're going to be effectively the exact same configuration and be a pool of resources that Kubernetes load balances for you.
And by shared namespace, it's like one domain, and inside of your container configuration, they share namespaces of different varieties.
Yep. So the Kubernetes will automatically inject DNS entries both for an internal pod communication. So if you have two containers in there, there'll be a DNS entry for each of the containers. So you can use a generic form to communicate between each other over TCP/IP if you need to. It'll also inject services that have been set up so that if you need to communicate with another service that's being hosted in the same namespace in Kubernetes, you can just put in my service name : port, as opposed to hard coding any actual specific pod or service name.
So off topic from security for a moment, how do you prevent database locking and like writing to the database?
Yep. So the database ones are a bit harder than, say, the web application themselves. So the databases are usually going to have a shared volume type thing if they're going to be sharing the same database. And so just like with the normal SQL Server and things like that, you do have to be careful of how you actually lock and what processes are doing updates at a given time. And that's usually going to be depending on what database controller you have. Usually, from what I've seen, if you have a one-off database controller like doing something SQLite, that's usually going to be in the container. The more heavier MongoDB or something else like that might be spun up in a slightly different way because of that shared database.
Yeah, interesting. That's really cool. So when you deploy, so you're kind of like hand in hand with the customer, similar to our previous interview with Sam from Logarithm. You're hand in hand with the customer. When you first like get this working for them and they start to see the results of Signal Sciences, what are some of the first things you see people doing and or reacting to that they didn't know about before they had this deployment?
Yeah, that's a great question. And surprisingly, the first thing is not necessarily something that jumps out as a security incident specifically. The expectation is I just installed Signal Sciences, I'm getting stuff in my dashboard. I immediately expect to see hundreds or thousands of attacks.
Yeah.
In reality, not everybody's running an attack against your site constantly. Maybe some sites are, but the majority I see are not. Usually the first thing that really grabs people's attention is the visibility and seeing things that are quite common, like 404s or 500s, but aren't things that you want in volume. So if you're seeing an IP 404 hundreds or thousands of times, either your application's broken or they're doing something a bit odd. So that's just something interesting. 500s are another one, seeing that your application is broken because it's giving an unhandled response is a great thing, especially if we're coming in via the security team as opposed to the DevOps team, that they can actually take to their engineers and say, hey, we have an unhandled exception. Here's criteria of why it's happening. And now this is a resolvable thing that they can actually go and fix. That's not necessarily security related. It might be because maybe something's getting out that shouldn't be with that unhandled exception, but is something that's just interesting to everyone.
That's awesome. Questions for Doug? Anyone?
Negative.
Awesome. So, Doug, do you have some kind of demo that you said you prepared?
Ooh, demos.
Yeah, I'll walk you through some pretty pictures and things like that of actual live data. I've set up an environment. Let me go ahead and share that because it's easier to see something. All right, so you should be able to see my whole desktop at this point.
Indeed,
We can.
I'll make it a little bit bigger so it's easier for anybody watching on a smaller screen. So this is actually the Signal Sciences dashboard. And this is what a customer sees when they first log in and start actually looking at data after the agent's installed. And in this demo, what I've done is I've actually set up a few different types of configurations. So Signal Sciences and this Kubernetes deployment is installed at the Nginx ingress controller, which is what we have here. We also have two microservices, one that I very originally called Apache and one that I very originally called Nginx. And then we have a third service.
So wait, I'm sorry, Doug. Are Apache and Nginx deployed inside of a container? So you're spinning up the web server inside of containers?
I am indeed.
Okay.
There are separate containers or pods in the ingress controller.
Mm-hmm. It's
So
interesting. Several years ago when I did the switch to containers, I did put my web server inside of its own container because I wanted the flexibility to do that. And that was at a time where I think people were kind of building too much inside of single containers. But I think the advice today is to have as many different containers as you can to represent your application because of the benefits to that, right? If I need to make a change to just a web server, if I need to deploy into Kubernetes and have scalability, you want to be as granular as possible in your app, right?
Yep, it's really how can you make it to one service in a container or a pod.
Yes.
And a service can be an Apache, it can be an Nginx, it can also be a Node.js service, it could be any of those above. And usually when I see Apache or Nginx as a microservice, they're really doing just one task, and they probably only have one virtual host defined.
And by having Node separate, then you get to pick like what UI you want to build on top of that, right?
Node.js, you can build your own UI, but usually the Node.js I've seen being things like API services.
Yeah.
So that Node.js might not have a UI in front of it, but it's just handling a specific set of API calls as its own listening service.
Right. So your front end could be React or Angular or whatever, but Node kind of sits in the middle between that and your backend app.
Yep.
This has not really very little to do with security, but a lot to do with application development. Thank you for that, Doug. I think it's great to kind of run my design by you for our applications. Thank you.
I think
my pleasure. I've been doing this now for going on 4 years, and it's
awesome.
Something I'm very passionate about.
Yeah, it's really cool.
Yep. And then
but hold on, Doug. To bring it back to security, I think that having this kind of sound architecture allows you to build security into this whole process way more easily, right?
Yep, and it actually introduces an interesting flow that you don't necessarily see when you have a traditional monolithic application.
Yeah.
So a lot of our, especially larger enterprise customers, they actually will install us at the ingress layer and at the microservice layer because they want to see that intercommunication between the microservices to see if maybe there's an internal actor that's compromised something or somebody's gotten into their environment.
That's interesting.
One of the scary things about Kubernetes is if you get a command execution that works with your web application, you now have access to a container that knows the namespace of that particular Kubernetes namespace. So I can find out all of your services, see what ports, and I'm now running in a more trusted environment.
Well, it's kind of like Active Directory, but for web apps.
Yeah, there's a lot of similarities. It gets pretty complex. I think some customers have 10,000 different microservices.
Right. That's awesome.
So what's the downside of making too many microservices? I mean, it seems like we used to not let things get too diverse because we worried about latency between different discrete components. But is that a problem?
I find the latency isn't usually as much of a problem because it's usually in the same cluster or data center.
Yeah.
So you're adding milliseconds for that hop, and they're doing one task, so they tend to actually run faster overall than a monolithic application. The issue tends to be a management and usefulness from what you actually see. So if you have 10,000 microservices, seeing each one individually becomes unmanageable. You have to start grouping those up into these 30 microservices make one application, and then view it at the quote unquote application layer as opposed to the individual microservice layer.
Yeah, it's interesting, Lee, when we do local development, we put our databases up in the cloud, but the app is actually running on our local computer. So it has to connect over the internet to connect to the database. And sometimes we'll be testing, and I'm like, why am I getting like this weird database error? I'm like, oh, connection like timed out kind of thing. And I just like refresh or do whatever I was doing again, and then it works. I don't think we've ever seen that issue in production because our app is running in AWS and our database is in RDS. And like Doug was saying, when you're like in the same cloud, even in the same cloud or even the same cluster, it's like milliseconds, whereas over the internet is pretty horrible.
Yeah.
Is that consistent with what you've experienced, Doug?
Yep, that's exactly how it works.
Yep.
So I was thinking of a story. Last night I was working with some guys on a problem they were having with their app that were in a container, and it was inconsistently. It's like there was a ghost in the machine. One component was hosed, and they couldn't find it. Finally, basically had to apply the universal Microsoft fix, as in shut it all down and bring it back up. That seems a little gross. Is that what reality looks like, or is that an anomaly kind of a case? Do you get ghosts in the machines when you've got all that microsegmentation?
Yeah, it depends on and this is, I think, really related to everything we talk about. It's not just having conscientious security during development, it's also having conscientious DevOps practices. So having the individual developers be responsible for their microservice and getting alerts and notifications. So when they break, they're informing up and having a way to report that structure. If you don't have a good framework in place for both the security and the kind of CI/CD approach for when things break, then the overall application is just going to break in unexpected ways.
So I need to know what I have and be monitoring it? That's crazy talk.
I know, imagine that.
Yeah, but when it's all in software, you can just respin it up. And there's a big difference between restarting the app and like rebuilding your entire environment. And to your problem, Lee, sometimes what I've seen is you just restart the service like within the container, but you're not rebuilding and redeploying the entire container, and you'll get very different results, right? Because some developer may have merged a change somewhere in the train that like doesn't take effect until that new environment is deployed. But there are some changes where you might just want to like restart the service within the container, and there's a sharp contrast between the two. So like you said, sometimes just like ripping everything down and redeploying it fixes your issue.
So is there any kind of best practice for when you should do that? Redeployment?
Pretty much always. Right, Doug? Like when in doubt, just like redeploy your infrastructure because it's all in code and software, right?
Right. Yeah, and if you're doing a good practice of naming your tags for your containers, you should be, okay, I deployed a new version, things started breaking unexpectedly, and you can then just revert back to the previous tag, which would be the previous known working space.
Yeah, that's something I haven't built yet, but I know is possible, and that's really cool. That's when I was a sysadmin deploying applications on actual hardware, something I wish I had more easily, right? It's just to just revert back to the previous version. Oh, well, that was a couple days ago, so you could go to your offsite backups and like restore the whole system. Those days are gone, thankfully. In this type of environment, anyway. So, Doug, tell us about some of the other more security related things that when you spin up the dashboard, however you're deploying Signal Sciences, that you start learning about.
Yep. So that's some of the things that we see here. And I have some scans running against my site that I configured. In this case, this is the particular Nginx cluster, but I could also look at the ingress controller and see if there's any attacks going in there. I have some from earlier. It just kind of depends.
So, Doug, basically what you're talking about is like the front end of the web server is every single, HTTP request and response, but the communication between your web server and your back end, whatever that is different, right?
Not necessarily. So most of the communication with inter-services, these tend to actually be HTTP responses. You'll see a lot of microservices running HTTP2 and various protocols underneath that. But one of the easiest and quickest ways for microservices to communicate is actually HTTP.
Yeah.
And that's usually what the ingress controller is doing.
But it's a different port. One is the browser communicating with the web server, and the other one is the web server making requests back to some application server. Yep.
So you'll have some Nginx ingress controller or something like that. In this case, we have it running on 31903 and 31949. These are my external ports.
Yep.
This is what the load balancer that would be sitting in front of your Kubernetes cluster is talking to. And these are talking to here. And then this ingress controller is talking to these two microservices on port 8282 each. And it's communicating via microservice-A and microservice-B as namespaces for how it forwards the traffic to them.
In this example, what's your application infrastructure? Is it like Java or like what's the app?
So in this simple example, this is the Apache and Nginx microservices. So microservice A is running an Nginx server, microservice B is running an Apache server.
I gotcha. So like your front end caching server is Nginx and your back end is Apache, sort of?
Yeah. These two, the A and B, don't talk together. The ingress controller, which also is Nginx, makes it a little bit confusing, is talking to them. So it might be the Nginx has static content that it's serving up,
right? And
the Apache might be serving up a Java page or a PHP page or something along those lines.
Yeah, I gotcha. It's awesome. And so Signal Sciences can monitor all that communication, regardless of your infrastructure. That's nice.
Exactly. And that's exactly what I've set up here, is going through and saying, okay, do I have anything going against Apache? No, I do have things going through the ingress controller, but not directly to the Apache. It's not being redirected to there. And I can jump through. Do I have anything with the Signal Sciences reverse proxy? Actually, I'm seeing I am hitting that, which lets me know that the attack is coming through the reverse proxy layer, which is actually forwarding to this Nginx sidecar.
Well, so even in front of your front-end Nginx, there's a reverse proxy that is the Signal Sciences code.
Yeah, just as an example to show different ways to do configurations in Kubernetes.
Gotcha. Nice. That's awesome. I mean, that's really kind of like independent of however you're putting your app out there. You can use this for not just performance testing, but security protections and all kinds of things, regardless of the implementation. That's nice.
Exactly. And we like to be able to work in any type of environment. So usually what I like to call the reverse proxy is the auto-scaling WAF. So you can set up a reverse proxy as its own service in front of other services. And this is usually the case. Security teams don't always have the ability to get the app owners to add in a WAF or make changes. Yeah. This allows them to transparently say, that's fine, don't change anything, and transparently just add a layer that sits in front and still provides the security that's needed without causing the app owners to make a change if they're not willing to.
And when the app owners say you're going to introduce a performance issue, how do you respond to that, Doug? Because I know you've fielded that question, right?
Quite a few times. So normally the agent gives a decision back on block or allow within probably 2 or 3 milliseconds. So there's not really much of an impact, especially because it's in the same cluster most of the time. You're adding, on average, maybe between 1 and 10 milliseconds to the request. And when it's at that transparent layer in front of the application, then from what I've seen, most of the app owners don't even notice that it's there.
I was going to say, in this day and age, does anybody really notice a 1 to 10 millisecond delay?
Probably not.
No, 100 to maybe 500 millisecond, yes, but when you're adding a few milliseconds, no, it's pretty much makes no difference.
I agree. I agree.
That was kind of my point.
Agree. Yeah, wholeheartedly agree.
Yep. I mean, imagine the delay when you're on dial-up. Like,
Yeah.
Well, I mean, you notice the delay when, like, 4G is congested or,
Yeah,
Wi-Fi.
I was gonna say, Larry, who the fuck is ever on dial-up?
I know. Well, sometimes it's like being on 4G.
Oh,
You notice the
Can you
delay.
measure the latency between the pieces? Can we track what we're seeing between it?
So the signal sciences side is going to show the attacks, and also when you're looking at the individual requests, you'll see information about what the total response time was. So we can see here that the total response time was 2 milliseconds for this response to get back to the web server, and then the web server still has to respond back to the client. But that kind of transaction that was reported to us was 2 milliseconds.
That's pretty good. I have responses that take way longer than that that cause you to do some analysis. So
I was thinking about, is it Joff on dial-up or is it my back end that's slow? So that works.
Yeah, it's a good way to point fingers and say, not me, and let somebody else on the network team
Works for my computer.
Mm-hmm.
Yep.
I don't want to talk about your slow back end, Larry. I mean,
Jeez.
Doug, what are some of the most common anomalies from a security perspective that people notice earlier rather than later in the deployment process?
Yeah, so there's a few. I would say some of the biggest anomaly that people notice are going to be the things like Tor traffic or no user agent.
Mm-hmm.
Those are ones because most of them, hey, why do we have things from Tor traffic? We're a normal site. We shouldn't really have that. So you see those here at the Tor traffic and data center. Then the other ones are, like I said, the no user agent. That's a big one because most people, unless they have a particular internal script or something along those lines, in this day and age, should have a user agent. I would like to say everyone does, but I see a lot of customers who don't. But it's a lot easier nowadays to have a user agent, and if there isn't, it might be a particular health check or something that you can very easily identify as something that's an okay script as opposed to something that's potentially malicious or anomalous.
I think it's becoming more common to block HTTP requests that have no user agent. I feel like that's a thing because when I was doing some API coding, I wasn't setting a user agent, and I was getting like a 403 forbidden.
Yep.
It was racking my brain, and I'm like, all right, hold on, let me set a user agent. And I set a user agent, and like magically all of my code started working. And I'm like, where's the documentation for that? Like, you know what I mean? Like, as a developer, that was really frustrating. From a security perspective, I'm like, oh, I get it.
Yeah, there's two main things that aren't like anything that people normally set up that I recommend out of the box as a first configuration is unless it's whitelisted to block requests with no user agent.
Mm-hmm.
And the other one is to block requests going to the VIP. Most often, you're going to have some kind of virtual host that customers should be going to.
Yep.
I'm going to www.domain.com, not my IP. It's very rare to have an external request that is valid if it's not an approved domain. So a lot of my customers, that's the first thing I say. If you're comfortable with it, let's set up a rule that will block everything except for the approved domains. And I did that on my own site. I host something called OwnCloud as opposed to using Dropbox. And after I did that, within a couple of weeks, I went from getting probably between 10 and 15 flagged IPs a week to I'm getting one every month or two.
Mm-hmm. Is that set in the header as the host?
Yep.
Mm. I noticed that too. Yeah, that has to be valid. In a lot of modern systems, you have to like really pay attention to that.
Yeah, and most people who are doing curl will just do curl IP and don't set a host header that's valid.
Yeah.
And that just immediately pops up as why don't you have a valid host header?
And for developers, that drives us nuts.
It does.
Because there's a
security,
lot
it's
of
really
coding in the. Well, so I ran into a situation where the API didn't support certain functionality, so I had to build the request header manually. And those were the two things that tripped me up. It was the user agent and the host header had to be like valid and set. Otherwise, I got a 403.
Yep. Yeah.
It sounds like they were using. It sounds like they were using your product, and I'll tell you who it was during the break. How about that?
Sounds good to me, and I'll let you know if it is one of them. But yeah, as a conscientious developer, and when I do scripts now, and I write a lot of them, is I always try to set a descriptive user agent so that if it's against my own systems and tools, I know it's me.
Yep.
And if it's somebody else, they can say, oh, yeah, okay, that makes sense. Let's allow it through.
Mm-hmm. Wow, this got really nerdy. It's awesome.
It's super nerdy.
And that's a problem?
No, absolutely. No,
Good.
it's good. It's a good thing. It's a good thing. I mean,
We like nerdy.
Yep, absolutely.
I'm
Joff
thinking-
has written applications that I'm sure you've run into these issues, Joff.
Yeah, I don't know what issue she's talking about, but yeah, certainly.
Joff has no issues with his applications ever.
Have I royally f things up? Yes. And learned some hard lessons. Yes, many times.
Yeah.
Lee, you had a comment in there?
Well, I was thinking about, if I'd had this technology back when I was trying to architect web applications back in the late 90s, where the idea of breaking them up and load balancing stuff was blowing management's mind, it would have been really cool.
The fact that you had to break things up
kidding,
and load
right?
balance them in the 90s is saying something.
That's pretty impressive, actually.
I was actually making a
actually
pitch to buy a
forward.
second 12 CPU Sun to split the load up and also give us some redundancy. And that was about a $45,000 purchase back then.
Yep,
Yeah.
It was not cheap, that's for sure.
Yep.
And the idea that state would go between system as the load moved around or something failed, that it would actually transfer. That was the part they didn't believe it for 1 second.
You got away cheap, 45 grand even back in the day.
Good discount.
Was the hardest thing when I was at Iron.io and having people do functions as a service. Designing things to be stateless and just pick up from where it left off was a fundamental shift for a lot of people.
Yeah, that was state was a big deal. I remember those days too.
Mhm.
I mean, it was not. Yeah, it was like, well, what do you mean? We got the cookies, we got this and that. Geez, yeah, it was a big deal.
Yeah.
Oh, I feel like today, if you can avoid cookies, you're doing good. We had that conversation the other day, actually, Jack and myself, and we were like, yeah, like we don't really use cookies in our application, and he was like, that's a good thing. I'm like, really? Because that was like a thing, like back in the day. Everyone was using.
Still is.
He's like, no, like today, if we can do
but if
without
you're
them, like it's a good thing, right?
If you're maintaining any kind of authentication state, what the fuck are you using then?
Well, yeah, but that's built into a lot of the frameworks today, Joff.
Yeah, well, you're using cookies.
Yeah, and it was right. We're still using it, but it's under the,
You may not be using it.
Yeah, but the framework is agreed.
Oh, right. So you're verifiably full of shit then, Paul.
Again, the day will come where I test the security in depth of our application, and I'll be horrified, like I have been going through line by line every single bit of our application.
Absolutely.
Right now, I'm like, oh my God, how does this even work right now?
And you know when I say that, Paul, I'm saying it with all the love in my heart, my friend.
Because Joff has also made those mistakes too.
And everything
As have I.
and everything is a process, and you work through it. But what I've learned, especially recently, and it's very pertinent in this conversation, is that how much functionality is king, right? Or queen, I mean, whatever it is, like functionality rules, like big time.
Make it work.
And we all, as security practitioners, we all know that, and we try and relate to that. But when you put yourself,
we have a hard time with that. We have a hard time with that.
And I agree, but we do have a hard time with that sometimes as well, right, Joff? But you put yourself in the shoes of the responsible person for that, and man, like functionality rules. Like I said to a couple of people I may even said it on our call with Doug, right? In prep for this segment. Even simple things like you're checking in a release to Git, and GitHub tells you, Paul, by the way, you've got some packages in your release that have some security vulnerabilities, and you might want to look into that. And I'm like, yeah, that's great. However, this really important piece of functionality in my app is broken. And by the way, once I fix that, I've got management breathing down my neck going, we really need to push this release. And so, like, what's broken and what features are coming next are first, and then second, and then what
security is third or fourth.
What GitHub is telling me about security is definitely third. And I'm like, now I know why. The software security can be so horrible. I get it now. I get it now. And we still have a lot of work to do to get software where it needs to be in terms of resiliency all around for all three of those scenarios.
Without a doubt.
How are we going to bring reality into the equation anyway? We're supposed to be setting arbitrary security norms that they can't meet. The hell with meeting the deliveries of the company. Come on.
I think it gets better over time, Lee, right? Because I think that my experience with a legacy application really puts a priority on bug fixes, features, and then security, right? But I think once you get over that hump, and it's funny you say that, Lee. Like I'm toiling in my mind. Like, if I had more resources, could I make more strides in security? And with security being so intertwined with, we're talking about development here and web app development, being so intertwined into that, I'm like, if I had more resources for security, those would really just be more resources for coding, and therefore, like, users and management would be like, well, you have more resources, so therefore you can implement our bug fixes and our features more quickly, not necessarily our security. So I'm really struggling with that point.
And they're really going to care about where it's broken and where it's not doing what they need. I mean, that's the deliverable. That's where the money comes from. People don't pay it to be more secure.
What's the tipping point between resources for features and bugs that allows you to get to, we've got enough resources for that, therefore the new resources that are coming on can focus on security and integrate with your bugs and features? Doug, I'd like to get your thoughts on that, because you're in a lot of different people's environments implementing code. Like, how are they balancing bugs and features and security as kind of a paradigm?
Very difficultly. Exactly the problem you outlined there. People hire resources and they tend to go straight towards features and releasing new versions of the product.
Yeah.
It's a standard problem that I think we've faced in the security industry for a long time. Cost avoidance versus cost savings, or cost, like gaining actual new customers. And usually what I've seen, the more successful organizations from a security practice is at a certain point, whether they had a breach, an audit, or there was some modifying or some motive event that caused them to say, we need to put our foot down, and we're actually going to dedicate a set of resources and money to a team that actually does this. I think something that I've seen in my personal experience is microservices is helping this.
Yes, agreed.
With this abstraction, you can now have frameworks that are just your security framework. All right, you don't want to bother your developers? That's fine. We're just going to put in a transparent layer that's doing security and that can scale and pretty much not cause you any problems. Oh, you are willing to do this? Here's a simple way to plug in a module, and now we get that visibility and we can start implementing security. But the biggest one is a partnership. The security teams are never going to be, as far as I can tell, fully funded, and they need to be partnered with the developers and app designers. And to do that, they need to introduce products that those teams will like and find useful. And that's something that our kind of founders and team have focused on. And in fact, more DevOps engineers bring us into their companies than the securities teams do. And that's a shift in the kind of practice in the community of, hey, let's be more security conscientious. Let's find tools and let's evolve security and actually have good security practices. And are there ways that code's always going to have a vulnerability, but is there ways that I can apply virtual patches or other methods to mitigate those vulnerabilities if and when they're found?
Yeah, and that's why I like the Signal Sciences solution, right? Because I think no matter how good you are at developing software, at developing secure software, reliable software, resilient software, that it comes down to, I mean, if you break it down to a very basic level, there are basically changes, right? Like whatever I've written, I've pushed it out. And if there's a bug or a feature or a security fix, it's a change. And changes fall into, like, if you break it down into very binary level, like there's easy and there's really super difficult, right? And developers are going to go like, when I push to testing and the test scripts and security testing find an easy thing, I'm going to fix it. Like, that's cool. Like, it's pretty easy, right? But oftentimes security pen testers like Joff and Larry and automated software even will find some kind of issue, regardless of what it is, and the developer looks at it and goes, crap, that falls in the like really hard to implement kind of feature, and that's going to take time. And that exposure, whatever it is, vulnerability exposure, whatever you want to call it, that risk is going to persist until such time you can like catch up and fix that. And really, there's going to be easy ones and there's going to be really hard ones. And those are really the two. I mean, sure, there's gray areas in between, but those of us that have done development know, like, some stuff is like really easy to fix and some stuff is like, yeah, that's a major architectural change and that's going to take weeks, months, whatever to fix. And that's why I think a lot of applications end up in the situation where they're like, yeah, that has a major vulnerability, right? And what's frustrating from us from a security perspective is a lot of times we look at that and we go, well, wait, that should be that should be in the easy category to fix, but for whatever reason it's not, right?
Yep. Yeah, and we get a lot of customers coming to us for, hey, can you help us set up effectively a virtual patch, a set of rules that's going to block particular types of requests until we can fix it in our product, and then we don't
buy us
care.
time. Yeah, buy us time. From a developer's perspective, that's important, right? Because I'm going to knock out whatever I can easily, and for the hard stuff, I'm going to be like going to Signal Sciences and my security. If you're truly integrated in a DevSecOps, as a developer, we go to the security team and be like, look, let's just have a frank conversation. To fix that is a lot of work. Like, I mean, a lot, like air quotes, like a lot of work. Like, you need to buy us some time so that we're protected until such time we can put those fixes in place. And oftentimes it's not the amount of time it takes to code the fix. Oftentimes, like, I don't know, there's a percentage of time that varies. It's a significant period of time where you're like, yeah, I put the fix in, but it was so fundamental the way the app worked that regression testing for that takes even longer because there's lots of different, dependencies. So I think what we fail to realize as security practitioners is not just the time to implement a fix, but to test it to make sure it doesn't break all of the other dependencies in the app.
Yep, testing is the hardest one, and testing for security is even harder because there's a lot of smart people out there. There's going to be a lot of those people out in Vegas next week, and they're always going to find something that was missed, and you go to fix that, that's going to introduce something else. So it's being as proactive as you can, but also being able to react quickly if you have missed something.
I think what I like to encourage is that if you want to get into development, is to get into the QA side and write some tests. I think so many developers are like, I want to code the fancy new features. I want to use the new technology. I want to do the new features. And Doug's laughing. The camera wasn't on him, but he's laughing because he knows exactly what I'm talking about, right? Because as a software developer, you're like, I want to code the new stuff. I want to code the cool stuff. But writing tests it's just not cool, right? But it's so important to be able to, and it's hard to be able to consider all those different scenarios to go, what if the user was to do A, B, and C and affect X, Y, and Z? Like my brain explodes sometimes of like, how do I change this thing? How do I go back and test to make sure it works? That's a really hard engineering problem, but so many developers and QA folks may shy away from that because it's so hard. But it's really sexy, right? It's not, in your minds, it may not be as sexy as implementing the latest, greatest feature, but like those tests are really super important.
As an end user, I want my stuff to work.
Yes.
I want some cool new features, but I also don't want to open up an app and just have things start crashing on me. So I definitely agree. And I've known some really good QA engineers in the past, and they're worth their weight in gold.
Absolutely.
Get those people who go, yeah, why would a customer ever do that? Well, why wouldn't they?
Yeah.
Because they can.
But the best users are the ones that are like, well, I use it this way and can articulate, here's how I used it and it broke.
Yeah.
Right? And I think a lot of developers get frustrated. Like your first reaction as a developer could be,
why are you doing that?
why are you doing that? I'm frustrated. But you should throw that thinking out the window and go, that user's thinking differently. And maybe they can't articulate it exactly right, but you got to look into that and go, oh, that's a scenario I hadn't considered. When hackers go after an application, we're going after scenarios that the developer didn't consider. Those are things you should latch onto, right?
Yeah.
Yep. The users that cause us the most grief are generally going to be our best pen testers in a lot of cases.
Yep.
I've seen often people design for RFCs, and that's great. But hackers or people who don't know what they're doing or how they should be using an application are going to be the ones who don't follow the RFC and break things and potentially cause vulnerabilities.
Yep.
Time and time again. Here's a standard. Implement the standard. Well, the standard can be interpreted multiple ways.
Header cases. At RFC is you have capital of each word in the header. But how many legacy apps have I seen where they have case-sensitive checks for the header to see if something's there, and you force a standard on it, and now your app's broken.
Yep.
It's really interesting. When we all studied tcpip for the first time, I think a lot of us gained insight as to how developers interpret requirements, right? And all those vulnerabilities we studied, most of them are largely a result of how the developer interpreted the standard and how the hacker looked at the standard and go, how can I deviate from that, right? And that's really the crux of so many security.
What a bunch of deviants.
Pretty much. Yeah, pretty much. It's very, very well put, Larry. Hey, Doug, are you ready to play 5 questions with Security Weekly?
I am.
Good, because all your team is listening.
That's right. No pressure. Every single person, no pressure, Doug. So, Doug, 3 words to describe yourself.
Let's see. Rollerblading, traveling, and slightly obsessive compulsive. That's more than one word.
That's more than 3 words.
That was 4.
So, but he's only slightly obsessive compulsive, so it's okay.
I think.
Okay, we'll give it to you. We'll give it to you.
Was that 3 or 4? Were you trying to do a buffer overflow rate in the first question? That's
trying
awesome.
to hack us.
That's
right
awesome.
there.
Clearly, he's violating the RFC.
Yep. Or did he? Or were there some air quotes? So we tried to group them.
That's right. Yeah. Doug, this next question is a free-form text field. If you were a serial killer, what would be your weapon of choice?
Hydrogen bomb.
No pause.
No pause. Also a free-form text field. If you were to book about yourself, what would the title be?
Gets way too caught up in coding.
This is a select field radio button. There's only 2 choices. In the popular game of Ask Grabby Grabby, do you prefer to go first or second?
If I didn't have to choose, neither. If I did, probably first, get it over with.
Choose 2 celebrities to be your parents.
Joff?
Alive, dead, fictional, or otherwise.
Probably Mila Jovovich and Ryan Gosling.
Oh.
Ooh, interesting choices.
I don't think we've ever heard those 2 answers before.
That's an interesting mix.
Well, Resident Evil, because, can't not have that. And then Ryan Gosling's just been in a bunch of cool things.
I like the you can't not have that, right? Like that speaks to your personality. There's no right or wrong answer, Doug.
Yes,
and I think that's fabulous.
I feel like Doug prepared. I think he prepared.
I think he. You know what? If you did, that makes you a good hacker. That's all. That's all I'm saying. So, Doug, thank you very much for appearing on this edition of Paul's Security Weekly.
My pleasure. Thanks for having me.
With that, we'll take a short break, come back with the security news for this week. Stay tuned.